So in this question here, I want to show for an integer n, 2n plus 1 squared minus 2n minus 1 squared divided by 4 is always even. Now let's have a look at what's going on here. So the terms in the brackets, I've got 2n plus 1 and I've got 2n minus 1. Now let's just assume n is, let's say, 7. 2n plus 1, that's going to lead me to 15. And 2n minus 1, that's going to lead me to 13. Now, when I square those numbers, let's take 15 squared, that's 225, and 13 squared is 169. Now, if I subtract those, I'm going to get 56. That's going to be the result when I subtract them. So dividing that by 4, I'm going to get an even number. 56 divided by 4. So 4 divided by 56, that gives me 14. So 14 is an even number. Now, any number you plug in for this n equals whatever here, you will always get a similar even number as a result. That's all well and good, putting an example number in there, but we need to show it using algebra. So when we got these terms here, 2n plus 1 squared minus 2n minus 1 squared, let's first of all expand out from the brackets. So 2n plus 1 squared. So 2n plus 1 times 2n plus 1. Let's start this down on this bottom line here. So divide that by 4, foiling this out. 2n times 2n, 4n squared. 2n times 1 is 2n. And then let's use the 1 plus 2n and plus 1. So that's my first term on the left hand side of my numerator. Now let's see what's happening on the right hand side of my numerator. So this time I've got 2n minus 1, 2n minus 1. And then let's FOIL it out the same way that we just did. So 2n times 2n, 4n squared. 2n times minus 1, that's minus 2n. Now let's distribute the minus 1. Minus 1 with 2n and minus 1 with minus 1. Minus 1 times 2n is another minus 2n. Minus 1 times minus 1 plus 1. Okay, now let's do some simplification on here, taking particular attention to this minus sign in the middle, because there's plenty of occasions here when this could go wrong for us. So 4n squared minus 4n squared, that's just going to give me 0. So they are going to cancel. So here I've got 2n plus 2n, so that's going to be positive 4n for these terms here. And here I've got a minus sign, and I've got minus 2n, minus 2n. These will become minus 4n inside here. But I've got this minus sign here. So 4n minus 4n gives me positive 8n. So that's going to go in my numerator. And I've got 1 and a minus 1. So that's just going to cancel out. So they will be gone as well. So now I'm left with 8n over 4. Okay. Now 8n divided by 4, I can divide everything by 4. That's valid. So that's now going to give me 2n. Now any integer that I plug in and multiply by 2, I'm always going to get an even number. So hence, always an even number. So that is good enough to show my answer. That 2n is always an even number, so this is always an even number. So that would be my final answer. And that'd be a good place to stop.